designed for test, designed for visibility, having the ability to actually watch your assay run.
Mhm.
How do you think about design for test, when you're looking at cartridges or in the early stages of development?
Another, I guess, to start off on a kind of a related tangent, manufacturing is a huge part of this entire exercise. Where cartridge design is something that cartridge manufacturing is something that have to get perfect because you're making hundreds, if not thousands, or maybe even millions of these disposables in order to support your product. So ultimately, you need with a really good manufacturing plan and talk to your manufacturing partner very early, to make sure that you're setting yourself up for success. But even oftentimes we end up, with a short-term and a long-term manufacturing plan to the point that you just made, and being able to have high visibility into your assay during development. So a lot of times, I guess there's no substitute for your eyes. If you have a cartridge and it's embedded deep into your instrument in a place that you can't see it, and you have an intermittent problem, you likely aren't going to be able. It's going to be very difficult for you to debug what's going on without having eyes on the system. So that can impact cartridge design in your short-term development phase, to make sure that you're preferably using something clear. And then also oftentimes we end up designing fixtures that are much more open than the final design in order to support, development work, as, fine tuning different like open loop commands or whatever as part of the assay.
Gotcha. So, yeah, having it be two-dimensional and see with your eyes is one way to do it. I guess talk to me a little bit more about, not to me, to our viewers, I suppose, uh, about some of the ways that we actually do or could do sort of in process assay checks, right?
Yeah.
So optics, pressure sensing. How are you doing it on projects these days?
Yeah, I think optics and pressure sensing are definitely like the most valuable. We've used lots of IR sensors, both reflective and through, in order to detect fluid presence. So we have a lot of experience in that, and it's definitely a super valuable way of confirming that things are going as designed, as intended. And then pressure is also a very valuable one as well. And so you can see whether you're getting cartridge leaks, or if filters are wetting out, things like that. So I think those are probably the best two if you're not going to be able to look at the whole cartridge visually.
So that's a good segue actually into serving our customers, right? Our customers are the assay scientists, and we are providing them these test beds effectively. Sometimes it's a piecemeal portion of a cartridge, other times it's the fully integrated cartridge, but either way, we're providing them this data throughout the assay to help them develop and de-risk their assay. So can you describe how Keytech optimally works with assay teams so that the assay stays king and the program is preserved as best as possible?
In an ideal world, we get direct FaceTime with the assay team regularly. And what regularly means might be different on a different project, but it's really important for the engineering team to understand the challenges that the assay team has, and vice versa, and so that we understand where does the risk lie, and that both helps us to solve and focus on the correct technical challenges, but also kind of helps to steer project direction. I guess one reason that we often do fixture work in order to support the assay team, usually these fixtures are being used by the assay team themselves in order to facilitate, faster testing or just more representative testing of what the product will ultimately do. But one reason that we often do that is to support guard banding testing, so that the chemistry team can help and hone in on the tolerances that are required on different aspects of the assay. So for instance, maybe you have a requirement for your temperature of your fluid to get to 95, but you might not know if that's okay if it's 94, or if it's 94 and a half, or 94 and three quarters. Basically, we design fixtures to kind of allow the chemistry team to play with different variables, whether it's temperature, whether it's volume, and kind of see what does and does not break the assay. That's one reason, I guess, that we do fixturing.
Got it. So describe a little bit more what you think the optimal sort of handoff points throughout a development program are.
Yeah, it definitely depends program to program. I think that there are times, when based off of engineering challenges that may be driven by, marketing rather than assay. There are times that engineering can provide feedback for to the assay, and they can kind of go a different direction. That doesn't always work, but like I have had experiences, where that's the case, where, we could use a different type of chemistry to account for the fact that this instrument's going to be super expensive because the tolerances on the heater. Like I was just as an example to reiterate, if those tolerances are really, really high, maybe it means that we need more expensive electronics, or, it's just a more complicated, larger instrument. So then we kind of have to push back on assay and say like, "Hey, how is a different way that we can do this? What parameters can we adjust to still be able to get the correct results, but also meet these other requirements?" So,
Gotcha.
yeah,
So yeah, it sounds like it's very much a dialogue, and that's probably the key word here. When you're looking at automating assays and putting prioritizing the assay, it's yes, the assay team ultimately is making some of the key. Will the measurement work or not? But there are other sort of strategic go to market, if you will, strategies or packaging, as you say, that will push back. So we're pushing back on cartridge cost, right? Because that's the razor blade, pushing back on instrument cost, and what are the different ways to, heat, cool, push fluids, all those sorts of key subsystems to drive the assay on the cartridge. So it's very much a dialogue. I totally agree. We show a process diagram, right, that shows, de-risk, identify the variables of interest by conducting a sensitivity analysis, a Bible, if you will, of all the steps of the assay. And then you develop the test fixtures to study those variables of interest. And then you learn, and then you architect the system. But in the show prep, you mentioned that it's kind of funny to try and conduct a sensitivity analysis initially. And you mentioned there were some challenges with that. What do you mean by that?
yeah. I think it's difficult because, like, in an ideal world, we would be able to come up with a really robust requirements set driven by assay that was defined, even before we're really, starting to dive deep in architecture development or just design in general. But functionally, there's a lot of times when when the design of the cartridge and the instrument can kind of fold back and shift those requirements, or cause us to take a second look at the way that they were, early guard banding studies might have been run. And sometimes those just need to be repeated in a more realistic sense. So I guess for an example, to give it some context, you might have a portion of the assay that's been typically run on a off-the-shelf PCR thermocycler in a 96 well plate or something like that. And in your actual cartridge, maybe your volumes are different, and for sure your aspect ratio is almost certainly going to be different. So maybe as opposed to that fluid being in a well, maybe it's in a channel, or a thin chamber or something like that, and the thermal uniformity, for instance, might be different in either of those scenarios. And it'll call into question, the original temperature requirements that were set based off of this early benchtop testing might not be applicable in this new situation. So requirements are always tricky. We're always questioning what's important, what's not important, but it is definitely something that needs to be revisited throughout the course of the project, and is a key part of why, a communication between the assay team and the design team is so important.
Awesome. Yeah, no, that's a great example. I hadn't even thought about that with the temperature uniformity changing. I imagine that similar sort of arguments apply for the other variables of interest, right? Like volume control, of course, temperature control, rehydration of lyophilized reagents,
Yeah.
mag beads too,
Hmm.
and other sort of lysing methods, right?
Yeah, definitely. Yeah, I could probably go down a spiel on anyone that is less fair.
Go, yeah, yeah. Yeah, that's the bait, I guess. Well, great. Yeah. So, I mean, I think it's great you've outlined some of the key challenges and with automating an assay on a system, and why it's important to have that continued dialogue, between a development team and your assay team working together at various key touch points early on, getting those test beds out to really understand what the variables of interest are after your sort of cursor evaluation on basically on a spreadsheet, or as you mentioned, a simple, 96 well plate sort of platform. So with that, Melanie, I guess, do you have any other high level learnings from being in the trenches these last couple years?
I'm not sure. I guess patience and due diligence. I feel like that's really all the product development's got as a whole. So, yep, stick with it, I suppose.
Great. Well, we'll definitely be doing that. We'll definitely be sticking with it. So, hey, thanks for your insights, Melanie. Appreciate it. And thanks, everybody. Don't forget to smash the like button there on YouTube and listen to more podcasts here in the future. We've got a big plan for 2022. Lots of new guests and topics to cover. So stay tuned, everybody. Thanks.